How many different wireless protocols do you know? It probably is not as many as this guy knows. Find out what I mean next.
You're watching IT Pro TV.
Wireless. I normally just think about Wi-Fi when I hear about wireless, but Mr. Wes Bryan assures me there's more to it than that, and so we need to find out. Wes, what are we talking about when we're not just talking about Wi-Fi?
That's right. We're going to be talking about numerous wireless protocols that we need to be aware of because, like Ronnie, myself too, when I first got into the industry, I thought wireless, well, we got to be talking about Wi-Fi. It's interesting because that only makes up a small subset of a larger umbrella topic that we need to talk about. So we're going to be talking about a variety of wireless protocols.
Sounds like a lot. Let's go ahead and head on over to the bench.
All right, everyone, come on over here at the bench. And full disclosure here, we've got a couple of programs that we're going to use really to drive this conversation. One, I have a wireless access point here that we're going to enter the configuration interface, and we're going to talk about what we see here. And another one is going to be a Wi-Fi analyzer so that we can really drive this discussion. Now, it's important to be able to have the conversations that I'm having with you all today, whether you're doing this for a certification endeavor or you're doing it for a support endeavor. Let me show you what I mean. So I'm connected to the wireless interface, if you will, or the web interface, I should say, of this wireless access point right here. And I pulled up the wireless settings page, and I want you to see that we have a set of frequencies. Now, this is important, and before we go any farther, I want you to know that in being able to identify various technologies, you have to know the frequencies because they also have some associated channels with them. And this is important, and it doesn't matter, like I said, whether you're going for certification. If you're going for certification, you need to know some of the specifications. But let me show you why it's also important in a help desk or a support desk role as well. If I zoom in here to this wireless access point, you will see that we have two different frequencies. We got the 2.4 gigahertz spectrum and we've got the 5 gigahertz spectrum. Now the question is, if you weren't in a certification endeavor, would you be able to support these? Would you be able to tell me what the channels are that we have available for these different frequencies? And if the answer is no, then you probably need to do a little bit more research and be able to identify that, and that's why we're having this conversation. Now, one of the ways that we can kind of see what channels we have for the different frequencies is through an application, that Wi-Fi analyzer that I opened up before the show started. Now, when we look at this, one of the things that you're going to see, the very first thing, and it's kind of hard to see, so let me zoom in. I want you to know that we're looking at the 2.4 gigahertz spectrum. Now, the 2.4 gigahertz spectrum is the most popular one that we have out there today as far as being so widely used. And because it's so widely used, it also has a lot of congestion with it. Basically, I want you to know there are 11 channels, but for a certification endeavor, what it's really important to know is that out of these 11 channels, one thing I want you to focus on is that we have 3 channels, and you can kind of tell this by these hills here, that do not overlap, and that's 1, 6, and all the way out here 11. And we don't have anything, any access point broadcasting a signal on 11. Why is that important? Notice some of the in-between channels. Notice how their signal overlaps with adjacent channels. That can cause performance problems. So remember that we have those 11 channels, but 1, 6, and 11 are the ones that you want to set your access point on if you have other access points within your network or within the proximity of your network. A lot of times, ladies and gentlemen, for a non-certification endeavor, you turn this to auto and you let the access point take care of it. One of the last things I want to kind of touch on when it comes to the frequencies is if I change over to the 5 gigahertz network, and let me see here, and that is down right here. All right, I could switch over to the 5 gigahertz network, and I want you to notice just right off the top, right? You see that, Ronnie, how these channel numbers just completely change? Well, that's because 5 gigahertz uses non-overlapping channels. There's 23 channels. You don't have to know each one of those channels. That's beyond the scope of this exam. But the big thing here is to know that the 5 gigahertz, because we have these non-overlapping channels, it's not as widely used. Now, it will become widely used because a lot of your modern technologies are using it today. So, the difference between the 2.4 gigahertz and the 5 gigahertz spectrum, 2.4 gigahertz, we have to remember 1, 6, and 11. With the 5 gigahertz spectrum, you don't have to worry about that overlap because of the fact that every one of these channels are non-overlapping. Be able to identify the frequencies and the channels associated with them so that you can support this technology.
Now, these aren't just put out there because there actually are going to be radio frequency waves. We tend to have different standards, right?
That's right, we do. And Ronnie, I can actually give you all a show of that right here. So for instance, I'm connected back to this wireless access point currently right now, and you can see this number 802.11. We'll talk just briefly what that letter designation means, but more specifically, I want you to focus on the 802.11. So what is 802.11? So 802.11 is a body of standards that's developed by the Institute for Electrical and Electronic Engineers, the IEEE. They basically promote standardized wireless communications under that 802.11 body of work. Now, there's a variety of the 802.11 standards, and we need you to be able to identify them. So follow me on over here, and I've got a little chart out here, and hopefully this is going to help you to make a little bit more sense of this. This is the time to make some flashcards if you're in certification endeavors. Take some notes if you're in a support endeavor, right? We have a series of attributes I want you to be aware of. We have the IEEE standard over here and the variety of the 802 standards that are available. We'll talk about 802.11 standards. We also have what's known as the Wi-Fi Alliance. This is a consortium of wireless manufacturers that also promote their own naming designations. I'll get to that just in a second. Notice that we have a series of frequencies that are available. For you that are studying for certifications and supporting this technology, these frequencies matter because it tells us which one of these are potentially interoperable, right? And that could be a gotcha if you're sitting a certification exam. You can also see some of the speeds. For instance, earlier legacy protocols would be at 54 megs, 11 and 54 megs, but then when we get to 802.11n, the one that you've seen on the access point, now we jump up because of the technology progresses to 600 megs. We get into AC and AX, if you will, and we now get to 7 and 10 gigs. Now, I want you to keep in mind that these are the theoretical speeds. It does not mean that you're actually going to get these speeds because of all the things that can slow down wireless communications. But I do want you to be aware of the chart, make some flashcards if you will, and it'll help you to support the technology. Now you're probably asking yourself, well, what's this right here? Well, starting with 802.11 AC, the Wi-Fi Alliance said, hey, all these numbers are confusing to the average person. And if you're like me, the average person, they were confusing as heck to me as well. So they said, how about we get a marketing naming convention that maybe makes a little more sense to the public? And that's when they came out with Wi-Fi 5 and Wi-Fi 6. That's what they call it versus the IEEE's official standardization. Wi-Fi 4 is just a retro name. They said, well, we already have N out there, so this is called 5 and 6. Let's just backwards name Wi-Fi 4. So if you see Wi-Fi 4, that's what they're talking about. Same thing down here. Again, take the time to do the work and get these under your belt. I can quote them. I know that because I've been supporting the technology for a long time, but I know you can do it as well, just putting a little bit of effort. So those are the 802.11 standards. It is one of those things that, well, it's not always the funnest stuff, right? We like to use the technologies. I don't know about you. I like to get into the technology. I like to actually use it. But sometimes, just like if you're learning a new language, you have to learn some of the specifications behind it.
Yeah, so when we start taking a look at that, that's probably by far one of the most popular technologies because it's been out there so long. But another technology that we want to talk about in wireless is going to be the idea of Bluetooth here. So share with us about that.
That's right, Bluetooth. Bluetooth is a very, very popular protocol because the goal is ease of use. Doesn't always work that way, but the goal is ease of use. Bluetooth is also one of those technologies that operates in that 2.4 gigahertz spectrum. And this is one of those technologies that has about a 10-meter range, if you will. So it doesn't go out that far, about 30 feet or so. And what your Bluetooth communication devices do is they go through a pairing process. First, they're put into a discovery phase where they're broadcasting their name so that other Bluetooth-enabled devices can find them. When these two devices try to connect, they go through a pairing process, and once the pairing process is done, then you can utilize the communications between these devices. Now, as far as Bluetooth specifications, if you're in exam endeavor, one of the things I want you to remember is that some of the later Bluetooth technologies were really focused on IoT devices. So in the earlier days of Bluetooth, because of Bluetooth being turned on and always trying to discover other devices out there, it would drain your battery pretty bad. It was right around Bluetooth 4.0 that they introduced Bluetooth plus LE, which is called low energy, and that means that those standards and after are now less power hungry. In fact, so much so when the marketers came out and they were saying, new Bluetooth technology is coming out, you can power your Bluetooth radio on a battery that's less than the size of a dime and it's going to last 10 years. Whether that's true or not, I don't know. That's maybe good marketing, but the point is that it does reduce the power consumption, which is why you're finding it more and more in these devices that don't have big battery lives, and it makes it a lot more efficient for a communication technology.
Yeah, so when we start talking about the idea, right, between just both of those, Wi-Fi, we tend to see, of course, things like our cell phones and tablets and even laptops a lot of times that those get on that. But what about Bluetooth? What do we tend to use with those?
Bluetooth, well, man, I tell you, you can do all kinds of things with Bluetooth. You can connect to things like, for instance, I know I use it for speakers. So I know I use it for things like earbuds, if you will. I use it also, too. Sometimes you have file transfer mechanisms that'll allow you to transfer over Bluetooth rather than going over your Wi-Fi. And that's also on mobile devices as well. So a lot of accessories can be connected to your laptop. If your computer has, your desktop, I should say, has a Bluetooth adapter in it, it can do it as well, your mobile devices. So a very versatile type protocol that can be used to connect accessories and other types of devices across the computing environment.
All right, so Wes, we need to move on and talk about near-field communication here. Now, according to what I see, it says that it's like 0 to 2 centimeters. What use is that?
That's right.
That's like less than an inch.
That's right, not much, right? Actually, it's a very, very important technology, and it's become very, very popular in mobile devices for things like contactless payment systems. If you've ever done an Apple Pay, right? Notice how close you have to get your phone or your iOS device to that point of sale system and touch it. Well, that's the centimeters. It's almost touching it, right? That's why I say 0, because once you're touching it, well, you're going to make a communication. All right. The other things that we use things like near field communication for, have you ever had to upgrade a phone and you have an old phone and it says, hey, just put your phones close to each other and we'll go ahead and we'll migrate your data to the new phone. Let's use an NFC to do that. Near field communication is a point-to-point contact type connection, if you will, that runs over 13.56 megahertz. We use it for things like asset tracking, contactless payment, proximity cards. It's another very good technology that you can use to transfer information.
Now, that sounds similar to something else for us here. Is RFID similar to this?
You know, they really are similar, Ronnie, when you think about the technology and what they're doing. RFID, radio frequency interference, it's another one of those technologies that one of the things I say, here's one of the stark differences, right, is the distance. Right, when we talk about near-field communication, that is a wireless communication that's you have to be very close. Radio frequency identifications, they use close to the same technology. They can have 2 different types of devices. Let me talk about the components, and then I can talk a little bit about the distance, right? The main components are 3 components. A tag, and the tag is a container that digitizes and stores information. You have a reader that reads that information out of the tag, and then you've got an antenna associated with the wireless communication. Now, one of the things I said is that it allows farther distances. You have unpowered tags, and unpowered tags have a distance that is as close to near-field communication, or maybe 10, 20 feet max. You have powered tags, and if you have a powered tag, you can send distances up to 100 meters, right? 100 meters, now we're talking about Wi-Fi levels, right? That's 328 feet, but it does require a powered tag. So near-field communication, RFID, really close. Really the thing I want you to keep in mind about the 2 is one travels a farther distance, one is a very short-range distance.
All right, now our particular subject here, which I think I wasn't sure, long-range fixed wireless. What is that about?
That's another thing that's trying to overcome some of the distance limitations of Wi-Fi, Ronnie. So Wi-Fi networks, you know, I didn't quote many of the distances because so many things affect wireless communication signals that can severely reduce the distance. All right, so a lot of times what you'll see is the higher the power, the shorter the distance. The shorter the power, the greater the distance, right? That's some of the trade-offs, right? Well, Wi-Fi is just going to be restrictive in distance anyways, right? 160 feet, maybe farther indoors, maybe a little bit farther outdoors, if you will, if you're close to the antenna. Well, what if you need a wireless communication up to 1 kilometer away? Well, you're not going to be able to use Wi-Fi. And that's where something like long-range fixed wireless comes in. This is where you have providers that use licensed and unlicensed bands, and they basically get to the ability to extend the reach of that wireless communication beyond the limitations of Wi-Fi. And again, sometimes up to 100 meters. So we're talking about a 328 feet distance communication. So why would that work really good? Well, if you need a line of sight communication from one building to the next, and your building is just outside that Wi-Fi range, well, guess what? You can't use Wi-Fi to communicate with your networks between buildings, but you could use something like a long-range fixed wireless. These are some of the wireless protocols that I would be able to explain if you're going to sit a certification exam. But as I've shown you, if you can't understand the technologies, then you can't support it. So also be able to identify these technologies if you're in that help desk role, and you'll be successful.
Thank you for watching IT Pro TV.